Hello students, in this class we will learn derivatives and integrals. So basically together what's called as calculus. Okay. So how to learn calculus formulae? This is our main problem and main stress what students get is memorizing the formulas of derivatives and integrals. Okay. So I have taken one simple formula of x raised to n. So simple f of x I have taken, that is x raised to n, and we will find its derivative and integral. So first of all, to make the things very simpler for students, you need not memorize. Like there are around 25 formulas of derivatives and respectively we have 25 formulas of integrals. Around, I am saying, okay? In which around 10 are basics. And even to learn those 10 basic formulas, we take so much efforts and we try to memorize, and in the middle of all that chaos we tend to forget it in the exam. Okay, now first you need to understand what do you mean by derivatives and integrals exactly. Okay, now derivative ka formula you know already. So x raised to n ka derivative is n x raised to n minus 1. This is the basic formula for derivative of x raised to n, and integral of x raised to n is given by x raised to n plus 1 upon n plus 1 plus c. This is a constant. Okay, c is a constant which you need to write for every indefinite integral. Okay, now how to remember this formula and how to apply this in the problems. Okay, first of all you need to know that derivative is anti-integral. So if you take derivative of something, let's say x raised to n, derivative is n x raised to n minus 1. Okay, so it means that derivative of x raised to n is n x raised to n minus 1. So this is the answer for x raised to n. Now, when I have written derivative is anti-integral, means what? If I take integral of this, my answer should be this. Okay? So derivative is anti-integral and integral is anti-derivative. So if you take integral of this, you will get the answer as x raised to n. Okay? Now, let us apply this in a problem. Let's get an example. Find the derivative of x cube. By taking this formula, you know that answer is, so d by dx of x cube is given as 3x raised to, now n minus 1 will be 3 minus 1, that's 2. Okay? d by dx of x cube is 3x square. So I have found out derivative of x cube, correct? Now, when I say that if I take integral of this answer, I should get x cube. Let us check. Now let's find integral of 3x square. When I have said integral is antiderivative, that means answer of integral of this should be x cube. X cube is what I have to get the answer. Let us check. Now putting this formula over here, so integral is represented like this. So integral 3x square dx you have to find out. Okay, this will be equal to, now 3 is constant, so take it out of integral x square dx, and the answer of this you know that it is x raised to n plus 1 upon n plus 1. What is n? 2. So n plus 1 will be, this 3 will come into x raised to 2 plus 1, that is 3 upon 3. So 2 plus 1 upon 2 plus 1, so 3 upon 3. This 3 gets cancelled and your answer is x cube, isn't it? So basically, when I found derivative of x cube, I got answer as 3x square. Us answer the integral if I found out, I got back x cube. Now you understand why is derivative called anti-integral and integral is called antiderivative. Okay? So we have found out derivative of x cube, answer is 3x square. Integral of this answer, I get back this answer. Okay? Now this is, I went from derivative to integral. Now what about integral to derivative? Now see, I will prove that integral is antiderivative. Okay? Find integral of x cube is the question. So integral x cube dx is what? X raised to 3 plus 1 upon 3 plus 1. By using this formula, I got the answer. Okay, you have to write plus c also. Okay? Plus c will come, but that's okay. Because answer of integral has constant. Okay? But you need to get this answer what is there. Okay? X raised to 4 upon 4 plus c is the answer. Now I want to find derivative of this particular function. When I find derivative of this, my answer should be x cubed. Okay, understood that? So I will find derivative of x raised to 4 upon 4. C you leave. Okay, actually if you take C also, constant का derivative is what? 0. Okay, so d by dx of x raised to 4 upon 4 will be equal to, let's add plus C also for you to understand what is happening. So this will be d by dx of x raised to 4 upon 4 plus d by dx of C. This is 0. 4 is constant, take out. So this will be 1 upon 4 d by dx of x raised to 4. What is derivative of x raised to 4? This formula I will use because you are finding derivative. So 1 upon 4 into 4x raised to 4 minus 1, that's 3. Okay? Plus 0. 4 cancel and you get x cube as the answer back. Okay? So basically, when I found out integral of a function and whatever answer I get, if I find derivative of that, I get back the same answer. Did you see? So, if you know the formula of derivatives, then to find integral it's very easy. Okay? Matlab derivative of f of x. If the answer is f dash of x, okay, I'll write it for you. If you find derivative of f of x, let us say my answer is f dash of x. This is how we denote the derivative. So this means that if I find integral of f dash of x with respect to x, my answer should be f of x plus c. Okay? So please remember this. If you take one more example, say find the derivative of say sin x. Okay? Now my f of x is sin x. Okay, so d by dx of sin x, everybody knows the answer is cos x. Okay? So my f dash of x is cos x over here. Okay? So if I take integral of cos x dx, I should get answer as sin x again with the positive sign because everybody is positive over here. Okay? So if I take integral of cos x dx, and yes, my answer is sin x because that's the formula. Okay? Did you understand this? This is a basic technique how you remember to find derivatives and integrals. Continuing with the calculus formulae, okay, I have made a table for you so that it becomes easy to understand the formulas of trigonometric functions, logarithmic function, e raised to x and x raised to n. Okay. Now, the first one, now what I have done is at the left side I have written all the derivatives, how to calculate derivatives. And the answers of them I have calculated integral of them for you to understand that derivative is nothing but anti-integral and integral is nothing but anti-derivative. Okay? Example. First one. If I find derivative of sec x, now d by dx of f of x, okay, will give me answer as f dash of x. That's the derivative. Okay? Sec x ka derivative is sec x multiplied by 10x. Okay? So if I take integral of sec x into 10x dx, the full thing if I take integral dx, I get answer as sec x plus c. Okay? The derivative of 10x is sec square x. So integral of sec square x will be 10x. Understood? Third one. Now here you have to pay attention because there is a minus sign. Derivative of cosec x is minus cosec x into cot x. There is a negative sign. Okay? So if you take integral of cosec x multiplied by cos x, so if you have this minus sign over here, then here minus sign won't come. Okay? But since I have taken only cosec x cot x out of here, then the minus sign transfers on the right hand side and it goes to cosec x. Understood? It's the same thing. Don't worry about the minus sign. Minus sign can be here or here. But remember that whenever there is cosec x cot x, there is always a negative sign. In the derivative also and there is integral also. Okay? Derivative of cot x is minus cosec square x. So integral of cosec square x is negative of cot x plus c. d by dx of log x is 1 upon x. So integral of 1 upon x will be log x plus c. This is the easiest formula to remember. There is no sort of confusion in this formula. So because derivative of e raised to x is e raised to x, okay, and integral of e raised to x is also e raised to x. Students will be very happy with e raised to x, okay. And the last one is what I had written earlier. d by dx of x raised to n is n into x raised to n minus 1, okay, and integral of only this much I am taking, integral of only this much x raised to n minus 1. So this n will come in the denominator on the right. Simple, okay. So x raised to n upon n plus c. And if you had put n over here, then n won't come over here, okay. It's the same, okay. So now let's change the function over here, okay. So derivative of f of x we had seen. Now we will see derivative of f of g of x. So basically instead of x we are taking g of x. So there is a function over here. So instead of x we have taken 2x over here, 5x cube, 2x. This is minus 7x square. Okay. We will change the x to g of x. So only difference what we get is derivative remains the same. Derivative of f is f dash, just like here, multiplied by derivative of g of x. So you have to take derivative of g of x and then multiply it. Okay. Let's take an example. First one is the d by dx of cos 2x. Here g of x is 2x. Okay. So derivative of cos is negative sign, as you all know. So minus sign of 2x. You need to write the angle first as it is and then multiply by derivative of 2x. Can you see that? Here 2x was there and multiply by derivative of 2x. What is derivative of 2x? That's 2. So my answer is minus 2 sine 2x. That's it. Minus 2 sine 2x. Okay? Second one. Derivative of sec of f of x is sec into 10. So sec g of x will be sec 5x cube into 10 5x cube. Okay. Multiplied by derivative of 5x cube. How to find derivative of 5x cube? d by dx of 5x cube will be, so 5 into 3 into x, 3x raised to 3 minus 1. That's 15x square. So 15x square is going to come over here. Okay? So this answer will be 15x square sec 5x cube into 10 5x cube. This is the answer. Understood? Third one is d by dx of log 2x. We all know that derivative of log is 1 upon x. Okay? Derivative of log x was 1 upon x, we saw last time. Now, derivative of log of g of x will be 1 upon g of x into derivative of g of x. Okay? So, 1 upon g of x, that's 2x, into derivative of 2x is 2. 2 and 2 is cancelled. The answer is 1 upon x again. Understood that? Okay. Next, this is student's favorite. This is friend. This is our friend because its derivative is easy. And what is that? E raised to x ka derivative is e raised to x. So e raised to g of x ka derivative is e raised to g of x. So write e raised to g of x as it is minus 7x square multiplied by derivative of minus 7x square. Derivative of minus 7x square is minus 7 is constant and x square ka derivative is 2x. So basically 7 into 2x. Okay? That's minus sign first. 7 into 2 is 14x e raised to minus 7x. Understood? I'll repeat it again. Let me write it clearly. Minus 7 into 2 into x. Okay? I'll repeat this. Derivative of e raised to g of x is e raised to g of x into g dash of x. See. Derivative of e raised to g of x is e raised to g of x into g dash of x. What is derivative of minus 7x square? Minus 7 is constant and derivative of x square is 2x here. Minus 7 into 2 is minus 14 x into this 14. Okay. Next we have 1 upon 2 root x. 1 upon 2 root x, first of all, 1 upon 2 you take as constant out and then take d by dx of 1 upon root x is a value. 1 upon root x can be written as x raised to minus half. Correct? So half into, now use the formula of x raised to n. X raised to n is n x raised to n minus 1. So n is minus half, x raised to n minus 1. So minus half minus 1. Minus half minus 1 is minus 3 by 2. I hope you know this. Okay? This answer is minus 1 upon 4 because half into half is 4 with a minus sign. X raised to minus 3 by 2. Finish. Next, little bit complicated. Minus 7 sin inverse of 2x. Sorry, positive 7 sin inverse of 2x. Keep 7 out. D by dx of sin inverse of 2x. Okay? What is the derivative of sin inverse of x? Sin inverse of x is 1 upon root 1 minus x square. Since it is g of x, it will be 1 upon root 1 minus g of x the whole square. Multiplied by derivative of g of x. What is the derivative of 2x? That's 2. This will be 14 upon root 1 minus 4x square. 2x the whole square is 4x. Done. That's the answer. And the last one is a quadratic equation you will get. See, if you cross multiply, you get x square plus 1 the whole upon x. This quadratic equation on top and denominator will be linear equation. Okay, but d by dx can be separated over here. Okay, just simply like that. D by dx of x plus d by dx of 1 upon x. You can separate like this. Okay. D by dx of x is 1 and d by dx of this will be x raised to minus 1 whose answer is again n x raised to n minus 1. So minus 1 into x raised to minus 2. This answer is 1 minus 1 upon x. I hope you got it.